How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss the properties of integers. This is a foundational topic in which these things will help you in solving different equations regardless whether there is a variable or just mere numbers. So before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners, welcome to our new session here in ML with Sir Ash. Today, we're going to discuss the most essential learning competency-based lessons for grade 7, quarter 1, week 4. This is entitled The Properties of Integers. Now, there are a lot of properties of integers, but we will be focusing on the properties that are being applied to operations on integers. And what are those? These are the closure, commutative, associative, distributive, identity, and inverse property. Now, our topic will tackle whether these properties are applied in every operation, such as the addition, subtraction, multiplication, and division. Okay, let's start. Okay, math learners, let's talk first about the closure property. According to the mathematicians and on our textbooks, closure property states that if ever A and B are integers, then the result will also be an integer, meaning the C will become an integer. Now, let's apply whether these are true. Okay, for addition, we say that A plus B is equal to C, meaning A and B here are numbers or integers. Therefore, we can say that C is also an integer. Let us try some examples. Let's say A is 5, our B is 7, and that will give us 12. 5 and 7 are integers, and 12 is also an integer. Then we can say that for closure property, addition is a part of the closure property. Okay, now let's consider subtraction. In subtraction, they say that if A minus 2B, the answer is C. A and B are integers, therefore the C will become an integer. Now, let's try whether this is true in subtraction. Let's say we have 10 minus 12 is equal to negative 2. 10 and 12 are integers, while negative 2 is also an integer. Then we can say that the closure property can also be applied in subtraction. Now, let us try multiplication. If we multiply A and B and they are both integers, then the answer is still an integer. Let's try. What if we have 4 times negative 3? The answer is negative 12. 4 and negative 3 are integers. The result is negative 12. Therefore, this is still correct. Now, whether we use negative 2 times negative 6, the answer is positive 12. And negative 2 and negative 6 are integers, then the result is also an integer. So, therefore, we can say that closure property is also applied in multiplication. Okay, easy, right? Now, let us go to division. It says that if A is divided to B, the answer is C. If an integer is divided by an integer, then the result will also be an integer. Now, let us try. We have 10 divided by 2. The answer is 5. It's correct. 10 divided by 2. 10 is an integer, 2 is an integer, and 5 is also an integer. Then this can be applied. Now, let's consider some other examples. If we have, let's say, 15 divided by 2, the answer is 7.5 or 15 over 2. 15 is an integer, 2 is also an integer. However, the result is not an integer. It is a rational number. Then we can say that this is not applied to most cases or to all of the cases, then we can say that closure property is not applicable to division. And that is all about closure property. Now, let us go to the second property. Okay, math learners, let us go to our second property, which is the commutative property. Now, according to the commutative property, it states that if two integers is being processed by an operation, regardless of whether you disarrange the position of those integers, the answer is still the same. Now, let's apply whether that is true to our operations. Now, in addition, it says that if A plus B, the answer is still the same as B plus A. That is the commutative property. Now, let us apply whether this is correct. Let's say 4 plus negative 3. Therefore, that will be our A and B. Therefore, the answer is just the same as negative 3 plus 4. Now, let's check. 4 plus negative 3, that will give us positive 1. Negative 3 plus 4, that will always give us positive 1. Therefore, that is correct. So, we can say that addition has a commutative property. Okay. Now, let us go to subtraction. It says that if A is subtracted by B, the answer is the same as B subtracted by A. Let's check. 10 minus 5 is just the same as 5 minus 10. Let's check whether that is true. 10 minus 5 is, very good, that is positive 5. 5 minus 10 is negative 5. And 5 and negative 5 are two different integers. Then we can say that commutative property is non-existent in our subtraction. So, we already have the first as addition, but denied in subtraction. Now, let us go to multiplication. It says that if A multiplied by B is just the same as B multiplied by A. Let's try. We have 3 times 7 is just the same as 7 times 3. 3 times 7 is positive 21. 7 times 3 is also positive 21. Therefore, we can say that in multiplication, commutative property is applied. Okay. Now, let us go to division. If A is divided by B, then we can say that B is divided by A. They are just the same as it could be. Let's say, or let's check or prove whether that is correct. If ever 10 divided by 2, the answer is just the same as 2 divided by 10. 10 divided by 2 is positive 5. 2 divided by 10 is, okay, that is 1/5. And 5 is not equal to 1/5. Therefore, we can say that division do not have commutative property. So, to generalize, commutative property can be applied in addition and multiplication only. Easy, right? Now, let us go to our third property. Okay, math learners, we are here in our third example or third property. That is the associative property. Now, what does the associative property states? Associative property states that if ever you have 3 integers, whether you start with the first 2 integers, it will not affect even if you start with the last 2 integers. Now, let us try whether that statement is true. If we have addition, A plus B plus C is equal to A plus B plus C, right? Of course. However, if you start with the first 2, the result will also be the same if you start with the last 2. Let's try whether that is correct. Okay. Suppose our A is 5, our B is negative 2, our C is 4. Same goes here. Okay. Now, let us start solving this one. And then in this part, we will solve first the last 2. Okay, let us check whether the results are correct. 5 plus negative 2, the answer is positive 3. Then we bring down 4. Negative 2 plus 4, the answer is positive 2. Now, let us check whether they are correct. 3 plus 4, that is 7. 5 plus 2, that is 7. So, we can say that associative property is applied in addition. Easy, right? Now, let us go to subtraction. In subtraction, it's just the same. We have A minus B minus C. Same goes here, A minus B minus C. We will start first with this one, and in the later part, or the right side, we will start with the last 2. Okay, let us check whether the property can be applied in subtraction. Okay, so we have 10 minus 3 minus 4. It is just the same as 10 minus 3 minus 4. Okay. Now, 10 minus 3 is 7. So that gives us 7 minus 4. We have here 3 minus 4. Okay. 3 minus 4 is negative 1. Okay. So now let us try to simplify. 7 minus 4 is positive 3. 10 minus negative 1 is positive 11. 3 and 11 is not equal. Therefore, we can say that associative property is not applied in subtraction. Okay. To sum it up, for addition, you can apply associative property, but in subtraction, you cannot apply associative property. Now, let's check multiplication and division. Okay, in multiplication, we have here, it says that ABC is just the same as ABC. However, if you multiply the first 2, it is just the same as if you multiply the last 2. Let us try to check. Let's consider this is 4. This is, let's say, negative 1. This is positive 2. Okay. So, same goes here. That is 4, negative 1, and positive 2. We will start multiplying first here, the first 2, while in the right side, we will multiply the last 2. Let's check whether associative property can be applied in multiplication. 4 times negative 1, that is negative 4. Multiplied by 2. Okay. 4, we bring down here. Negative 1 times 2, that is negative 2. Okay. So, negative 4 times 2, that is negative 8. 4 times negative 2, that is still negative 8. Therefore, we can say that associative property can be applied here in multiplication. And that is correct. Now, let us go to division. We have A divided by B divided by C. It's just the same as A divided by B divided by C, such that if we start the first 2, this is just the same as we start with the last 2. Let us check whether that is correct. Let's say A is 10, B is, okay, let's give bigger number. Okay, so let's say A is 40, B is, let's say, 2, and C is 10. Okay. We have here 4, 2, and 10. So you start here, and then we start here, the first 2. Okay. So 40 divided by 2, that is 20 divided by 10. Okay. While here, 4, we copy that one. Sorry, 40. 40. Okay, 40. 40, we copy. So 2 divided by 10, that is what? 2 divided by 10. That is 1/5. Okay, so that is 1/5. Or 0.2 if you make it as decimal number. So that is 0.2. Now, if we divide 20 by 10, the answer is 2. However, if we divide 40 by 0.2, the answer is 200. So, we can say that 2 and 200 are not the same. Therefore, we conclude that associative property is not applicable in the operation of division. Okay, so to sum it up, associative property can be applied in addition and multiplication only. Okay, now let us go to the distributive property. Okay, math learners, in the distributive property, this is a combination of addition and multiplication. It says that if A is a multiplier to the sum of B and C, we can say that if you distribute A to the B and C, AB and AC are just the same. Okay, let me clear that up. This is a multiplier. These are two addends. If you distribute this to the inside, you will not solve this first inside, okay? The answer is still the same. Okay, now let us try to apply it in an example or with numbers. Let's say our A is 2. Our B here is 5. Our C is 7. Okay. That is just the same as saying that 2 times 5 plus 2 times 7. So this is how distributive property works. Okay? So that is like this. Now let us check whether that statement or that property is true. Now here, of course, you can solve this one, right? So 5 plus 7, that is 12. Okay, 12. Multiplied by 2. Okay. And the final answer here is 24. Now, let us try whether that statement, or on the right side, whether we apply our distributive property, that is still the same. 2 times 5 is 10. 2 times 7 is 14. 10 plus 14 is 24. Therefore, we can say that distributive property can be applied in this scenario. Okay? So, whether you solve it by like this, or you apply the distributive property and solve it like this, in solving equations, you can still prove that your answer is correct. Easy, right? Now, let us go to the identity property. Okay, math learners, we are now down to our second to the last property, which is all about identity property. Now, identity property states that a certain identity element is being applied to a number, the result is its identity or the number itself. Now, for addition and subtraction, the identity element is 0, while for multiplication and division, the identity element is 1. Now, let us check whether this is correct. A plus 0 or 0 plus A, the answer is still the identity of that number, which is A. A minus 0 is equal to A, or 0 minus A is equal to A. Now, we will check this later whether the statements are true to all operations. A times 1 is equal to A, or 1 times A is equal to A. Here, A divided by 1 is A. 1 divided by A is A. Okay. Now, let's check whether these are all true in each scenario. Okay. Now, let's consider that A is 6. Okay. So, 6 plus 0 is equal to 6. Is that correct? Yes, that is correct. Okay. 0 plus 6 is equal to 6. Is that correct? Okay, that's correct. Therefore, we can say that identity property can be applied here in addition. Okay, now let's go to subtraction. 6 minus 0 is equal to 6. That's correct. 0 minus 6 is equal to, the answer is negative 6. It is not the identity of that number. Therefore, this is wrong. So, we can say that in subtraction, we don't have any identity property. Okay? At all times. Maybe in some other cases, but not at all times. So, to be sure, we will just consider false. Okay. Now, let's go to multiplication. 6 times 1 is equal to 6. That's correct. Alright? 1 times 6 is equal to 6, and that is also correct. Therefore, we can say that identity property is applied to multiplication. Now, let us try with division. We have 6 divided by 1 is equal to 6. That's correct. 1 divided by 6 is still 1 over 6. And that is wrong. Therefore, we can say that in subtraction and division, identity property is not applied, while in addition and multiplication, identity property can be considered. Easy, right? Now, let us go to the last property. Okay, math learners, we are down to our final property, which is the inverse property. Inverse property states that if an integer is added, subtracted, multiplied, or divided by its inverse property or inverse element or inverse number, the result is the identity element. Okay, math learners, we have here our inverse property. It says here that for the addition, if we add a number to its inverse, the answer is the identity element. Okay, let us check whether these are correct. Now, remember, in addition and subtraction, the inverse property is its opposite value. While in multiplication and division, the inverse property or inverse element is the reciprocal. Okay, let us check with the numbers. Now, let's say the value of our A is positive 3. So, for addition, we have 3 plus negative 3. The answer is, okay, 3 plus negative 3, the answer is 0. And they are just the same. So, therefore, our inverse property can be applied in addition. How about in subtraction? 3 minus negative 3. Okay, 3 minus negative 3, the answer will be positive 6. And this is not the identity element. Therefore, inverse property is not applied in subtraction. Now, let us go to multiplication. Again, in multiplication and division, it is the reciprocal of the integer in order to get its identity element. Okay, A times 1 over A. So, let's say that is 3 times 1/3. Okay, so how do we multiply 3 times its fraction, which is 1/3? So, first, we multiply it to the numerator, then divide it to the denominator. 3 times 1, that is 3. 3 divided by 3, that is 1. Okay, so therefore, they are correct. Okay, so inverse property can be applied in multiplication. And finally, we have here division. So we have 3 divided by 1 over 3. The answer is, so remember, in the process of dividing fractions, our dividend will stay the same. However, our divide will become multiplication, and our divisor will be taken its reciprocal and proceed to multiplication. So, 3 times 3, that is 9. 9 divided by 1 is 9. And 9 and 1, they are not the same. Therefore, it is not the identity element. We cannot say that inverse property is applied in division. So, to generalize, inverse property can be applied in addition and multiplication. So, math learners, I hope that these properties, you may never observe it while you are solving in various algebraic equation or expression, but this is very handy if these properties are inculcated in your minds. Now, this is the time that I will be challenging you whether you have mastered or you have learned the competency for this session. And here it is. Okay, I hope math learners, you have learned a lot of things for this session. This is still your free access math teacher Ash, and always remember, it is fun to learn mathematics if we are together learning. Thank you for sharing this video, and if you have any questions, do not hesitate to put your comments down below. Take care and have a great day. Fellow math learners, if you think you like this video, hit the like button and the subscribe button. That is, if you are committed of learning mathematics the easy way. Thank you.